Mr. Udeet Mehta. Mr. Udeet believes in a multi-disciplinary approach to architecture that traverses urban and rural planning, community development, and sustainable habitats. He was previously working on city-scale slum redevelopment projects in different parts of India. He has, over the last 6 years, been training architects in India to use energy modeling tools in design strategy so as to develop energy efficient and sustainable building design. So, let's welcome Mr. Udeet Mehta.
I'm just going to take up my involvement with solar being fairly specific from the energy simulation approach. And I also want to, through some of the things I'm going to talk about, also approach solar not only from energy generation as electricity generation, but also apply this a little differently in terms of what we consider to be harnessing solar energy. Right, so there are various different ways in which one can harness solar energy. One of them is through solar PV, which most of us are aware of, where we convert sunlight into electricity. Another is where we look at solar heating, where we're looking at a cold climate, passive design. The more well-known one is solar PV, whereas there is also solar heating, which is for cold climate, passive design. And so this is something that is applicable in India in certain places where we have cold climate. However, for the hot climate, allowing this solar heat into our spaces is a no-no. Then we look at solar collectors, where we concentrate the sun's heat and use that higher temperature to either use hot water or to use steam and then generate energy. So there's another approach to how we can harness that solar energy coming in from the sun. And finally, there is a directly applicable way in which we can use the heat of the sun to create cooling for our indoor air. And this is something that is rather counterintuitive, but at the same time, we know that this is already being rolled out in China, and this is also available in India. So there are ways in which we can also approach this, but not all of it happens through solar PV. Now, at the same time, we also know that India's targets and commitments to generating renewable energy is something that is being led by the solar energy generation. And we have just become the world's number 5th producer of solar in terms of how much production we're able to increase over the number of years that we've made this commitment for. So, so there is a huge focus on solar PV because there is a certain direct access that end users can have. They can put it up onto their homes if their circumstances allow. And this is something that also the government is subsidizing and helping people to set up these solar PV panels. So let's understand a passive design to approaching buildings, and how we are consistently looking at how solar PV or renewable energy, once added to a building, makes that building extremely energy efficient. But this is not the case. So solar PV is something that is only adding a small part, which comes in later. Whereas before that, the design of the building itself focuses primarily on heat avoidance, that is protecting it from the sun, cutting off the sun's direct access to the building facade, to the building envelope, and then looking at passive cooling strategies, which is ventilation, humidity control, things where we are able to use the context of the building to integrate with the final space that we create inside and the experienced temperature. And then when that fails, there are certain points in the year where we have to put in mechanical cooling. And these mechanical cooling systems will have a certain amount of energy demand. So the idea is to first take away as much energy demand as we can by designing the building in a certain way, and then finally arriving at the absolute minimum amount of energy that we need to power these mechanical cooling systems for specific points of the year where passive cooling fails. And then after we arrive at that mechanical cooling bit, we then have to look at bringing in the fourth part, which is renewable energy, to come in and take care of that energy, that little bit of energy that we still have a demand for. Now, what we're doing right now is we are saying that we are going to continue living the lifestyle or continue designing buildings in a conventional way, right? Mostly our building stock is still coming up in the same way where we still have glass buildings coming in, where heat avoidance has not been looked at as yet, but the aesthetic has replaced that primary element. And then after that, we directly look at taking that energy from the grid to cool that glass building. And then we add solar on top of that, which says that, okay, we are also generating some energy. While we generate so much cooling demand, we also generate some amount of renewable energy. So there is a very important thing to look at: what is the percentage of consumption versus the percentage that we're generating. And so why the glass building or the glass facade doesn't work or fails in hot climates becomes very important for us to harness that solar energy. Because when we're looking at the sun's rays, we know that there is long wave and short wave both, right? Only the short wave radiation is what goes through the glass, and long wave cannot pass through glass. Now, once this short wave becomes, hits an object inside, it's then going to become long wave radiation, which cannot escape through that glass. So it's a one-way funnel by which we're allowing the heat to only enter, but we're not allowing it to escape. Right? So this is the greenhouse effect. And so when we look at this, we need to think of where our focus has to be in terms of the design of the building, and then understanding how that building can also add on to the best approach to generating your energy through solar. Now, the energy modeling tools for solar focus on understanding the maximum amount of output, and focus on understanding what are the points in the year where the sun is going to be located at different angles from the building, and then also it's going to help maximize that exposure of the building to the sun, right? So whether it's the rooftop, wherever we decide to place our solar, we're going to maximize the exposure to the sun. And so it's very important to now see how on one side we're trying to shade ourselves, protect ourselves, and cut us off from the sun, while on the other hand, when we bring in solar PV, we're trying to maximize our exposure to the sun. And so there is a clash when it comes to the design approach as to which one do we do. Okay, and so it's very important to therefore place this PV panel or the energy generation zone well away from the building, well ventilated, or separately on a separate land parcel, which is not going to pass that heat onto the building. So this is one major challenge where if we work in isolation, we're not going to be able to find a solution. But these two need to speak to each other and understand the design of the building being shading specific, yet maximizing exposure to the sun. Now coming back to that energy consumption versus generation, here we can see that the generation is the yellow and red graph below, which is only going to happen for a certain period of the day, right? And only for a certain part of the year when we don't have the monsoons, when we don't have cloudy skies. And on top, we see an energy consumption pattern, which is essentially going to constantly continue throughout the year, right? Whether we have solar energy coming in or not, we are going to have this energy consumption. And today our energy consumption is only increasing with time. So is solar really going to take care of the entire energy consumption? And if we want to bring it closer to our energy consumption rates, then is there also a need for us to reflect and to see, is it possible for us to bring down our energy consumption? Is it possible for us to also bring down our energy demands as a first step? And then the solar energy that we continue to increase in generation can at some point meet, and we can at some point completely be independent of a separate grid electricity, which is currently primarily a thermal-based energy generation. Some of this also relates to our demands. So when we talk about our demands and we say, I need my space to be cool, comfortable for me to function properly as a human being. So 40% of our energy consumption is on a cooling device, on an air conditioner. So if we can think about things like, am I really uncomfortable at a certain temperature, or can I push that temperature a little higher? Detailed studies have been done where we know that humans adapt to the temperatures in which they're born in or which they live in. So if you're from a hot climate, you're going to be comfortable at higher temperatures. If you're from a cold climate, you're going to be comfortable at slightly colder temperatures. So this band that we need to shift, rather than keeping a fixed band, which is on the left side, where we see that there's a fixed higher and lower band, that it has to be within 21 to 23 degrees. And similarly with humidity. And if we question that and say maybe we need to revise and reset those temperatures to what it really is required for us in our own individual climate types, then at that point, we've suddenly made a shift in terms of energy consumption. We're now no more demanding more energy for our temperatures to reach an exact 21 or a 23, but rather we're comfortable to look at temperatures that are slightly higher because we have adapted as our bodies have also adapted, right? So thinking about adaptive versus universal thermal comfort approaches. The other thought is also when we offset solar, when we offset the heat of the sun, the undesirable heat of the sun, at that point, we're actually harnessing solar energy to keep our spaces cool. So there is actually an energy offset that we do by making sure that sun's heat isn't coming into our spaces. And this becomes a very different way of calculating it, where by bringing down your energy bills, by making more passive strategies in your building, you are already generating that much energy, right? So it's kind of a correlation of how much you save is how much additionally you're generating and are able to use better or use differently. So this is in a way looking at how to harness solar, especially with the vegetation. This is another approach where if you're able to grow your own food, grow plants that are also going to be productive landscapes, that are going to cool your building and give you a saving from your cooling, but also going to generate food, which is another saving in terms of running costs. So there's going to be harnessing that solar energy, but for food and not only for cooling. All right. This is another way to harness your solar energy when you're using thermal capacity in buildings. So when you're using thermal capacity, you're working with the envelope of the building to absorb that heat. And then in the nighttime, when there's a complete change in temperature, you're using that building's heat to keep your inside of the building warmer and more comfortable. So you're using that heat, you're storing it with the building itself, and then you're using it again as heat. So it's heat of the sun being used in terms of heat, but also in terms of cooling. So they're both working together and maintaining a more standard internal temperature by using thermal capacity. So again, this is a non-active approach. You're not going to spend energy to ensure that this temperature differential is achieved. At the same time, you're also saving energy, which you would otherwise do for cooling. This is another building. This is a building project which I have designed and worked on, where we're using the path of the sun to create the path that we follow on ground and match that movement of the sun to the shape of our roof. And so on that roof, then we're able to have the maximum amount of offset of heat. And it also gives us the opportunity to consider using PV or certain other materials where we can harness the heat of the sun and maximize energy generation. Thank you. Thank you very much.